What's up, nerds? Harbinger here. Long time no listen to, I guess. I'm here with Grinch on the screen. He's my absolute favorite fictional character. A lot of you know why. You know, he steals Christmas from an entire town. As someone that has moved, I have a hard time moving in a relatively long amount of time, and he pretty much moves every Who in Whoville overnight with Max the dog. He leaves crumbs much too small for other Who's mouses. All he leaves is hooks and some wire. He doesn't even leave a log for their fire. Like, the Grinch is like this bad dude that, you know, look at, like, he's cocking his hat all, you know, it's business time and I'm going to steal your Christmas. Seriously, my life will be a success if I steal Christmas for an entire town. Part of me wishes Elon Musk or somebody else awesome like that would just go, you know what, we don't need to go to Mars. My goal is to steal Christmas for a town. You know, but the Who's handled it like champions. And then, for some odd reason, the Grinch's heart gains like 3 sizes that day. Come on, Grinch. You gotta go full Sith. Anyway, I'm not doing a daily meme. I don't know. I'm all memed out, and my memes aren't nearly as dank as some of my students' memes. So instead, I'm going to switch to a song recommendation. So please don't think that every single song I recommend is 100%, you know, G-rated. Sometimes they might have a swear word, and that doesn't mean I nor Syracuse as a school district endorses bad language. But I do appreciate quality music, and you can consider this to be like old man proselytizing to the youth about how much better their music is than the youth's music. And I know some of you are going to disagree with some of the stuff, and some of you are definitely going to agree. And if you give it a listen, that's fantastic. My song for the day, I guess, would be Where Did You Sleep Last Night from Nirvana. It's from the Unplugged. It's their very last song. I'm not going to play the song. I'm not going to do the video. Just give it a look at some point. It's Where Did You Sleep Last Night. It's a cover. And if someone ever wants to know how awesome Nirvana is, I don't say, hey, listen to Teen Spirit. You know, they didn't do Teen Spirit in this concert. Instead, they did a bunch of lesser-known songs and covers, and Where Did You Sleep Last Night ends it. And legend has it that when they were walking off the set and the producer said, wait, you gotta go do like a comeback, you gotta go do an encore. Kurt's response, he looked at her and said, but how do you top that? This song is phenomenal from beginning to end, and the end is the absolute best ending for a song. This is why Nirvana is Hall of Fame. So, Where'd You Sleep Last Night? Nirvana, it's phenomenal. Says the kid who went to high school in the 1990s. Anyway, we're going to do loops, odds, and ends today. I feel like there's some stuff we should talk about. And we're going to start off with some basic loop stuff. I'm going to do like a basic for loop, because why not? What I'm going to do is I'm going to just start counting up from 1, and I want to make sure I hit like the first 1,000 integers up from 1. So, I want to just say hello, because I'm so friendly. You know me. So, since out of that print line, hello. So far, so good. But you know what? If I ever encounter a number that's, I don't know, maybe it has a 7, or maybe it's a multiple of 7, I don't want to say hello. I want to say like 7 alert, or something like that. So the first one's easy, right? Like if m is a multiple of 7. So if m mod 7 equals 0, multiple of 7. So far so good. You know what? Maybe I don't want to make it, if it has a 7, just say 7 alert. Instead, I'm going to make it so if it has a 7 in it, I'm not even going to put out the number at all. Right? I'm just going to like skip it. So what I'm going to do is I'm going to say something like, I wrote a static method up here that handles that. It says, does it have? So I've got a static method that takes in a number and a target value. In this case, target's going to be 7. And if that number has the target value in it somewhere, then it returns true, else it returns false. So I wrote 2 lines of code. I could have made it 1. You know, hey, I turned num into a string, and then I used index of to search for the target. And it returns the truth value. Remember, return with some parentheses after it means return the truth value of this. So this means, is it there? So I think I called it does it have, and my num is m, and my target value is 7. And if it has it, so if m has a 7 in it somewhere, then I don't want to print out anything. I'm going to do the word continue. In fact, I'm going to move this line of code up. There. So what this does, it says hello every single time. Right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So even if it has a 7 in it, it's still going to say hello because, you know, we're friendly people. But if it has a 7, heck, and it's the same as this, equals equals true is the exact same thing, but I'm terse here with my code. If it has a 7, continue means skip this iteration of the loop. Don't do the stuff underneath, just skip on to the next number. So it'll say hello for m equals 1. It'll say hello for m equals 2. It'll say hello for 3, 4, 5, 6. It will say hello for m equals 7 because it's here. But then it gets down here and it's like, oh, 7 has a 7. Skip the rest of the loop. Skips this. Move on to 8. Hello when m is 8, 9, 10, 11, 12, 13, 14. When m gets to 14, it says hello. It doesn't have a 7 in it, but it is a multiple of 7, so for 14 it'll say multiple of 7. So the only time this is a multiple of 7 is for when m is a multiple of 7, but doesn't have a 7 in it. So 14 will say multiple of 7, 21 will, let's see, 28 will, 35, 42, all the way up to 70. When m gets 70, it'll say hello, but won't say multiple of 7. That's kind of goofy. So continue. All continue does, and it's I don't think it's ever been on the AP test, but it's legal for it. Skips one iteration of the loop. So far, so good. Now, what if I really am biased, and you know what, 7's cool and all, but if, let's say, does it have let's say like a 1 followed by a 3, so 13. So if you look at the code, since it turns it into a string, it's literally if there's a 1 followed by a 3 anywhere in there. So the number 13 will trigger this, right? The number 130 will trigger that one. 913 would trigger it. So there's a lot of numbers that will trigger this. If it has a 13, you know what? Break. That's it. So break stops the loop from running. Like, it stops the loop entirely. It won't continue on to the next thing. Continue just says, hey, skip the rest of this and keep running your loop over and over and over. But this is just like a skip this thing. Break says stop the loop entirely. Break kind of jumps to the end of the loop automatically and just says, hey, start running the stuff after the loop. I've been told that a lot of colleges frown on the use of continue and break, and I can see their points. I think OCC and RIT in particular have said if you're using continue and break, it means you didn't make your loop conditions smartly. You know, like you didn't structure this part smartly enough, and you should do a better job. I get that. That makes sense to me. However, you have to understand that continue and break are keywords in Java, especially when it comes to you know, like writing for loops. They exist for while loops, but moving on past that. All right, I also wrote a prime checker. I don't know if you saw that one. I tried to make an efficient prime checker, but I didn't rack my brain trying to come up with the most efficient thing ever. It takes in a number. I count from 2 up to and including the square root of it. Right, that's my upper bound. It's a smarter upper bound than I would have done otherwise. And if any variable in that range is a factor of num, it's clearly not prime. If I make it all the way to the end of the loop, it's prime. So I'm going to use that in a second. What I want to do is I want to output all the primes, but first I do want to talk about that Pythagorean Theorem problem you had on for loop lab. It's the last one. I don't want to give everything away, but some of you were doing the problem where you had to check, hey, there's a Pythagorean triple whose numbers all add up to 1,000 or something like that, and some people were trying some really goofy stuff, and it made me laugh. So and you had to use a for loop. So I loved, there was one about, I think, hey Seabear, I'm calling you out for this one. I think Seabear said something like, let's not call it T, let's call it like W. You know what, Chris Bauer. So Seabear equals 1. And while Seabear is greater than 0, you know, something funny like that. So he knows he's going to run, and he said something like CB++. So this is an infinite loop. you're looking at it right now and you're thinking, okay, 1, well, is greater than 0, and I'm going to keep going up and up and up and up. So that just runs forever. And he said something like int leg 1 equals, I think he said a. Random number. That. And then he did the same thing for B, and he did the same thing for C. So he randomly picked 3 integers. And then he checked. And then if he ever found a situation that worked, so he had something like, if A times A plus da-da-da-da-da, and they added up to 1,000 or something like that, then he used the break command. Well, I think first he SOP'd them, because otherwise what's the point? But that's one way, and I liked that way a lot because he used a for loop. In theory, it could run forever, or it could run instantaneously and solve it instantaneously. But whatever, it's kind of funny to do it that way. That's one way. What I really liked, though, is other people said, well, what if I didn't have to just use one for loop? I never said I did use one for loop. So somebody said, can I put a loop inside of a loop? And I said, you absolutely can. Thanks for asking. You could do that. Heck, you could even do, if you really wanted, a loop inside a loop inside a loop. That works. That way you can check an A value against every single possible B value against every single possible C value. And if you're wondering how many times this loop runs, it doesn't run 1,000 times. This loop runs 1,000 times. This one would run 1,000 times for every time this one runs. So this one runs 1,000 squared. And this one runs 1,000 times for every time this one runs, which is this one runs 1,000 times every time this one runs. This one runs 1,000 cubed times. Which sounds really, really big, but the computer kind of, chuckles at that. But even then, it's a kind of a big runtime, but not horrible. Anyway, this is called nested loops. Nested loops are a thing. They're helpful. You might want to try them for that for loop lab at the very end. Anyway, what I do want to do is maybe I want to output every prime. Output every prime less than 10,000. Right? That's not that bad. So really what's happening here is maybe I'm not smart enough to use my awesome is prime thing. Because if I use is prime, if you think about it, that actually goes pretty quickly. So I could say something like if is prime A, so A is 1, then 2, then 3, then 4, then 5, then 6, then 7, all the way up to 10,000. It would feed it up into here and it would tell me if it's prime or not. Sorry, I said up to 10,000. Up to, but not including 10,000. So if that's true, I could SOP A. That's it. Literally, if I wanted to output every single prime number less than 10,000, this is the code for it, assuming you also have my static method. What if you don't have the static method? Then what? And let's do it like we would normally do it in class. So int factors equals 0. I could do that one. And I've got this for loop because I've got to run the for loop from, let's see, well, if A is 1, nothing's going to happen. If it's 2, okay, I want to count how many factors 2 has, and 2 has 1 in itself. So, like potential factor right here that we're going to check, let's call it CH to check if it's a factor or not. So I'm going to run it from 1 up to, oh my gosh, what's my upper bound? My upper bound is actually A. If I'm checking to see if, let's say A is like 5,103. Is 5,103 prime? I don't know, but I would have to run CH from 1 up to 5,103, right? And the next time it goes through the loop, hey, A is 5,104. And every single time, that value that I'm checking right now is my upper bound for the prime check. So I'm going to run it like that. So that's not that bad. I think this part's really hard for a lot of people the first time they do this. I used to just throw them to the wolves and say, hey, go figure it out. You've got this upper bound. Deal with it. And people got confused a lot. Like, wait, what do I put here? They can see the 1 thing. They can see the int factors equals 0 thing. I get that one. The part that makes me sad is when people put it up here because it will never set factors back to 0. You know, like, hey, I'm factor counting, and they say 2 is the only prime number. I don't get that. That's because they don't reset factors. You can put int factors equals 0 up here, as long as you have factors equals 0 right here. But whatever, I'm going to move it back to where, oh, a plague on both your houses. There. I'm going to move it there, just, you know, whatever. So int if ch mod a, and I think a lot of people don't like the fact that they've got to use 2 variables here instead of just some number they're checking. But if I'm checking a, here I am doing it wrong too. I'm checking if a is prime, which means I'm checking a against every possible factor that I'm checking. So if at true, then factors plus plus. And then after this loop ends, if factors is 2, well, then it's prime, right? So I can say SOP, a is prime, okay. That's not that bad. And I'm not going to do it for if it's composite, right? I only want to see the primes. So output every prime less than this one doesn't. You know, what it does is a is, so let's say a is like 13, right? Let's skip to a later part of the loop. CH is going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to see if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is a factor of 13. And since 13 has 2 factors, it's going to say 13 is prime. The next time it runs through the loop, hey, a is now 14. Factors is set to 0. CH is going to run from 1 up through 14. So it's going to run again and again and again. It runs the inner loop over and over and over and over and over and over until this condition is done. Then it stops, it comes down here, and then it does the outer loop again. And when the outer loop jumps up to like 15, it's going to do this loop over and over and over and over and over and over. So I think a really cool question is, how many total times is this statement checked? And if you think about it, it's this number times, it's like a bounds multiplying problem, but this number is slowly increasing. So we got to be really careful. That's why it's important to have efficient prime checks, because your runtime can vary greatly depending on how efficient you are. But anyway, this is a nice way to output all the primes less than 10,000. So I used to give really big pain in the butt problems, like, can you give me every single prime that has a 6 somewhere in there and is digits sum to, you know, like, I don't know, 19, and has a digit product of 30. I don't even know if that's a thing, if there are numbers like that. And so people would have to write loop upon loop upon loop, like loops within loops within loops. I get that. That's cool. In truth, it's easy to write static methods just to check them. The second you write a static method like this, you don't have to worry about a loop inside of a loop. But right now, considering we're talking about loops inside of loops, you have to know that it's a thing. What people really like and hate about loops inside loops is one of these. So maybe whatever, you know, mistype, I can fix it. So I'm going to say something equal to that. I'm going to say something like that. So literally print, please note it does not say println. And then I'm going to put the println down here. And I don't have to put anything inside the parentheses. So your question you've got to deal with is, what does this print out? It makes a shape. The question is, what shape? And I'm not telling you here, but feel free to post a comment in the YouTube stream. Please, it makes a shape. What does it do? And then what happens if I switch this 7 to an X? Does the shape change? How does it change? Does it make a different shape? What does it make? So typically when people learn nested loops, they've got to deal with those two problems. Hey, what does this make? And what does that make? And can you make other shapes too? So just be advised, there's shape drawing too, and the AP test loves to put nested loops with the system.out.print and a character and what shape is drawn. Can you make a hollow shape? You know, there's a little bit more to it than that too, but please be careful. And can you make the shape upside down? Can you make it backwards? Stuff like that. These can be really weird, tricky problems, and it's hard to visualize. Anyway, I think that's it. You know, it's 20 minutes. We talked about breaks. We talked about continues. We talked about static methods inside loops. We talked about loops inside loops. And we talked about, hey, shape drawing. So a little bit of odds and ends. Last thing I gotta say, I guess, is Nirvana, Where'd You Sleep Last Night? Sweet, sweet song. Thanks to my 100 plus subscribers. I know I hit 100, and then I hit 101, and then it went down to 99, and then someone else was a 100 subscriber, and it went down, and someone else was a 100 subscriber. I do have my 100 subscriber. You gotta stay tuned for the 100 subscriber special. We're definitely doing something cool. But last but not least, Harbinger out!